too small. We try to make it larger. Eh? What? Eh? And R minus what? Prove, to prove. How we prove this? You need to use the formula for factorial or for combination, those numbers. Like here. We cannot make it larger. Oh, we can make it large. Okay, nice. Oh, prove the first part. Left-hand side, n factorial, r minus 1 factorial, n minus r plus 1 factorial. This definition of NCR plus n factorial, r factorial, n minus r factorial. That's left-hand side. But how we combine them together? It's like this, guys. For example, we try to use some examples. 10C7 plus 10, maybe we use smaller number. 10C2 or 10C3 plus 10C4. If you use factorial, you got 10 factorial, 3 factorial, 7 factorial, 10 factorial, 6 factorial, 4 factorial. If we try to make a common denominator, Charlotte, what's the common denominator? We try to add them up. What's the common denominator? For example, 3 factorial and 4 factorial. What's the common multiple? Oh, not a factor. We say 3 factorial and 4 factorial. What's the lowest common multiple? This one equals 3 times 2 times 1. This one equals 4 times 3 times 2 times 1. So the lowest common multiple, just 4 factorial. Multiple. Check out this one and this one. The highest common factor is 6. But the lowest common multiple, just 24. This is 6. This is 24. What's the lowest common multiple? 24. That's why if you need a common denominator, we need a 4 factorial. 4 factorial. For the other part, Eden. The other part, we got 7 factorial and 6 factorial. What's the common multiple? Common multiple. Lowest common multiple of 7 factorial and 6 factorial. What's that? Yes, 7 factorial. Now, for this one, we need times by 7. For this one, we need the times by 4. Check if you understand. This is the hard part. How you do some calculation about the factorial. We use the larger number for multiple. So we have here. 10 factorial times 4 plus 10 factorial times 7. So you got 10 factorial times by 11. Y times by 11 4 plus 7. Yeah, we don't calculate the value we try to keep it. 4 factorial, we just keep it. This is 4 plus 7 give you 11. Oh, and this one, what's the 11 C4? We just have 11 factorial, 4 factorial, 7 factorial. That's called the 11 C4. Oh, y times by 4? Okay, let's have a look at y we times by 4. Original denominator is 3 factorial, right? Times 7 factorial. Now you change to 4 factorial times 7 factorial. What you did? You times by 4. 3 factorial times by 4. We got 4 factorial. If denominator times by 4, the top times by 4. And y, the second one, we times by 7, Edward. Here, 4 factorial. Here, 6 factorial, change to 7 factorial. What you did? we just times by 7. Because 6 factorial times by 7, we got 7 factorial. That's why here we times by 7. That's how we simplify. It's not easy. Let's check more. Okay, let's check the okay. I just gave you the numbers. Hope you can understand some idea a little bit more. Do mosquito or something? Mosquito? Okay, okay. The question, the actual question, like here, can you simplify this one? Can you simplify this one? Like you have here and here. For these two, what's the common multiple? Eden. R factorial. For these two, Charlotte, what's the common multiple? Very good. Factorial. Now, what do you need times for the numerator? This part is very hard. Calculating using factorial. Okay. So for the numerator now, Isabella, for the first part, first term, what's the numerator?
N factorial times R.
Excellent. Katrina, for the second one, what's the numerator?
N factorial times brackets n minus r plus 1.
Very good. Now, if you combine these two, we got, they all have n factorial. Take it out. R plus n minus r plus 1. This part just gave you n plus 1, which means n plus 1 factorial r factorial n plus 1 minus r factorial. That's the left-hand side. Right-hand side, n plus 1 factorial r factorial n plus 1 minus r factorial. Same. Therefore, you don't have to write it. You just say equals right-hand side. That's how we prove it. How we prove it using factorial. Okay. But we can do the question asks you use factorial. We can do the other way to prove it. For example, oh yeah, like this part is n factorial times n plus 1, which is n plus 1 factorial. It's like 4 factorial times by 5, you have 5 factorial. Okay, Isabella, did you learn something called combination, permutation?
The nation.
Permutation, number of arrangement.
No.
Oh,
Wait.
good. Oh. Guys, now we can check induction. Induction. I will try. This is like ask to prove binomial theorem. This binomial theorem formula, they ask you to use induction to prove it. Okay, let's do it. I think last week we learned a lot induction. Okay. Induction. Eden, remember first step? Oh yeah, like if you need to prove it, n equals 1. This is a positive integer, so start from 1 on. Left hand side, right hand side. Assume pk is true. Hey, what equals what for pk plus 1? What? Right hand side. You try to prove these two sides same. Okay. When you one, just got a plus x. Left hand side, a plus x to power 1. A plus x. Right hand side is n0 up to nn. N equals 1, which means 1, 0 up to 1, 1. So just 2 are 1, 0 plus 1, 1. Same as a plus x. P1 is true. PK is true. Yeah, a lot. Like a K0, AK, K1, AK minus 1x, K, KK, XK. That's PK. Yeah. Yeah, for K plus 1. Left hand side is a plus x to the power of K plus 1. We need to use the result in previous part. So you need to rewrite it. K. If you rewrite like this, just times 1 more bracket. You can use this part now. So left hand side equals K0 AK KK XK A plus X. We try to understand the question. So you better write more terms in the brackets. Like here, you can write K0 AK K1 AK minus 1x K2 AK minus 2x squared. Okay, we write a bit more. Now times by a plus x. Expanded. Here, K0 just 1. K0 just 1. So KC0 just 1. So just AK plus 1 plus K0 AK X times the second one plus the second one times the other two. K1 AK X K1 AK minus 1 X squared. Oh, I just expand this one with bracket, this one with bracket. Guys, try to expand the other two. And you use dot on. Yeah, I use the first term and second term. We try to finish the third term. Yeah, sometimes if you hard understand, just write a bit more in induction. Okay. Selman, continue. Using this one times this two. K2 AK minus 1 X squared. K2 AK minus 2 X3. Okay. Now, what happened? What's this? What's this? AK plus 1. What's this two? This will have, if I wrote here, double check Y on. And next one. Do you understand this two? Well, do you understand this two?
Yeah.
Why?
Because that's what happened in part 1.
Oh, very good. Yes, because K0 plus K1 just equals K plus 1. That's from part 1. Okay. So dot, the last one time just xk plus 1. You can say it's equals right-hand side. And here, because it's 1, k plus 1, 0 also give you 1. So you can just say k plus 1, 0. Here's k plus k. K plus 1, k plus 1. Think about some details back home. We move on. Okay. Based on